Good morning, Romain and Couillet. So thank you so much for accepting the invitation and giving us a seminar. It's an honor that you are here in TII to present to make your presentation on AI versus planetary limits. So you are world renowned for your work on random matrix theory and all the applications related to massive MIMO, wireless communication, but also machine learning and signal processing. And you are currently a full professor at the University Grenoble-Alpes in France. And now you are giving a presentation on something that is a bit different from random matrix theory, since you decided from quite recently to rethink how to contribute in the research when we have planetary limits. So I give you the floor, Romain, and thank you again for coming.
Yeah, sure. Thanks. So, well, don't hesitate to say if you have a problem hearing, and also don't hesitate to interrupt for questions. So indeed, I've been working all of my career so far on large dimensional statistics applied to many technologies. So starting with wireless communications and recently on artificial intelligence. I've loved it up until recently. Well, okay, it was a pleasure to play with those mathematics. It's really exciting, but then I somehow overnight realized, well, not really overnight, but came to realize that all of what we're doing is well, actually useless and even dangerous, actually, when considering the planetary limits, the fact that we have our technologies, generally speaking, it's not just AI, it's not just the digital domain, it's everything that we are doing since at least 70 years or 200 years, that has been going too crazily far, and we need to change that. And changing that is not making a small step aside. This is really stopping everything, in my opinion now. So I've stopped working on those domains. I don't regret it, because now I discover a whole new domain that is much, much more exciting. I'll try to discuss that. But then, so the talk is about explaining what is the current situation. So let facing the facts. Well, figures that you guys have heard already, but just making all of them together and seeing what we can do out of it. Well, I say that I discovered a world that is more enthusiastic than before, very exciting, but I remain extremely pessimistic with respect to our capability of changing things. We will need to change. I'll discuss that at the end. We need a severe change of attitude, change of way of living, and that doesn't just come from mathematics. But again, I'm going to cover that in the second part. So I'll see how far I can go. So I'll start with the situation. So explaining that, well, we can start with mathematics, actually. I don't know if you guys have already heard about this so-called World 3 scenario, which is a mathematical model that's been designed now 50 years ago in the 70s. So here I give a reference to a book, but it's a recent version of it. So it's been designed in the 70s. It's a model of the world based on well, actually it's more complicated than it looks like here. It's 150 equations that regulate how the different components of the world interact to each other. And already in the 70s, people had realized that the way we live, so the fact that especially the orange curve, which is the number of industrial production that we ask from the planet, which is a finite dimensional object, the number of resources and that we extract, and the services that we bring out of it, the goods that we bring out of it, as it escalates, makes it that, and as our population is growing simultaneously, which is still going on today, it puts a high pressure on the level of pollution, because everything that we make with our current technology, so extracting metals and using oil and fossil fuels, creates, as you know, many pollution. So pollution is not only CO2; it's all of the pollutions that the Earth cannot regulate by itself. So this extreme increase, that is actually exponential increase of pollution, makes it that we have to buy more and more energy to cover for this pollution. So as our resources are finite, so resources are not just oil, it's also resources in metal, resources in wood, resources in all of the things we need to sustain the goods that we produce and to fight against pollution. Those resources will decay very quickly to cover for pollution and to ensure the goods and services per inhabitant that we ask. And well, the ultimate outcome of this, it's already been predicted in the 70s, is that at some point everything will drop. This is what they call a collapse. And this is very natural. There's nothing very smart out of it. The way it works is that at some point, we spend so much resource in order to fight the exponential growth of pollution that at some point we cannot use those resources to produce the goods and services per inhabitant. So we'll have to abandon part of it, and abandoning part of it is in particular abandoning our hospitals, abandoning many things that make us live. And also at some point, since we create pollution out of our agricultural sector, so the fact that we erode our soils and that our food production is going to drop, this is inevitable. This is already the case today. Worldwide, the food production is dropping. So at some point it's going to drop, and obviously if food production is dropping, that means that the population cannot survive, and there will be a drop in population. And if you look at the position where it's been predicted that we will have a collapse, it's something around 2030, 2035. The problem is that this graph that was designed in the 70s is still applicable today. So the curves as of today, 2022, they still fit perfectly. And we see the slope changing. So we know so far that the World 3 model is correct and that we are inevitably going in this direction unless we change things, unless we apply other policies. And this is what I'm going to discuss. So this is this slide that explains that if we keep going, so this is what they call the business as usual scenario. If we keep going, if we keep thinking that technologies will save us, well, we are dead. We are dead, and in a matter of 10 years, 20 years, well, some countries are already what they call failing, like Yemen, the south of Pakistan. There are places on Earth where you cannot live any longer because it's too hot, because it's too unstable. And so, well, this is inevitable. This is what's coming to all of the Western the Western world. So we have to admit it, and then that means we have to change one way or another. Let me just focus a bit on figures, just to tell you that it's not just models, so it's actual figures that I'm going to discuss related to the global energy domain, and then the digital domain, and then AI, since I'm supposed to talk about AI. There is something extremely simple. I think this is the key figure, if you guys want to remember something. The key figure that tells you everything, at least if we have a focus on CO2 production. So we know that CO2 production makes the planet heat, overheat, and this is the reason why we have already almost exceeded the 1.5 degree that was a target 10 years ago for the end of the century. We are already coming to it in a matter of a few years. So what we knew in 2011 from the 2011 IPCC report, IPCC said, so it's the International Panel for Climate Change, this panel of specialists said that in order to fall below an excess of 2 degrees on the planet, we have, as of 2011, a quota of 1,000 gigatons of CO2 that we can emit forever. So from 2011 to the end of the times, we are allowed to put from within the Earth into the atmosphere 1,000 gigatons of CO2. Okay. Problem is that today the current rate of release of CO2 emissions in the world is 40 gigatons. So the calculus is easily made. You divide 1,000 by 40 and you get something like, what is it, 25 years that you can keep producing the same quantity, and then we all go live in the forest because we cannot produce anymore. Or more reasonably, we have to produce less and less year after year in such a way that if you integrate this curve that decays exponentially from 2011 to the end of the time, we should not exceed 1,000 gigatons if we want to be compatible with the plus 2 degree quota. The problem is that if you do the calculus, it's easy to do. It's undergraduate exercise. If you do that, you realize that we need to have, as of 2022, because, well, turns out that from 2011 to 2022, we haven't reduced the quantity of CO2 emissions. If you do the calculus, we have, as of 2022, to drop our quantity of CO2 emissions. And so all of our economical sector, because it's all completely related, by a factor of 7% per year. So this is what I'm showing here. So it's not really updated. What the curve says is that this is the current trajectory of CO2 emissions in black. If we want to reach the target that I'm talking about, and we start in 2018, so it's already gone for this one, we have to reduce by 5% per year our CO2 emissions, or again, our economical sector, because it's completely equivalent today. Or if we wait until 2025, and since we haven't started yet, we can expect that we will wait at least until 2025. We need to have a decay of 10% of our world activity every year. You have to know that 10% per year has never been seen on the planet, but in war times. So doing it voluntarily has never been seen before. But this is what we have to do. We don't have a choice. Otherwise, we are going all the way to plus 3 degrees, plus 4 degrees, and that's the end of the world, to be clear. The end of the world before the end of the century. So we are all concerned. It's not just our kids. We are all concerned. So you see the amplitude of the task. If we talk about the digital sector, so we need to go. So let's just remember this. If we start today to decrease our intensity of emissions, economical sector, we need to decay by 7%. Let's remember the 7%. And let's look at what we are doing on the digital sector. There has been many simulations, but the most accurate one is the one in light green, which is this one. The current way the digital sector is going is by an increase of plus 9% per year. So we must do worldwide, all sectors together by minus 7% per year. We are currently going at plus 9% per year on the digital sector. So which is, when you compare to other sectors, is at least twice the rate of increase of all other sectors. So the digital domain is well, most likely the biggest problem we have, because it's increasing too fast. As we will see, it's highly demanding in terms of energy, in terms of material. So, and most importantly, that's something I think I'm not discussing, but most importantly, the digital sector now covers all other sectors. So even in agriculture, you have digital everywhere in the tractors, in the in all of the equipments in agriculture, you have digital everywhere. So we are completely dependent. We are stuck with a digital domain that, well, let's face it, if you shut down electricity tomorrow, we are all dead in a matter of a few months. Well, actually in a matter of a month. And this is not just some sort of a nightmare or something. This is already happening in Lebanon. This is happening in countries that are supposedly wealthy. And obviously this is already the case in Africa for quite a while. So we are in a position where we are linked strongly to a digital domain that has to survive on electricity production, on energy production that is for the time being 85% non-renewable, and that we cannot afford any longer. And so we are stuck. We are in this position that, okay, when this is shut down, we are dead, and well, we have to do something out of it. And the problem is that we are not going in this direction. It looks as if we didn't know, as if we don't care. I don't know what's happening, but it turns out that in terms of the quantity of data that is shared across the internet, it keeps going at a rate that is over linear, so almost exponential. So this is the quantity of exabytes per month of data that is shared across the internet. And so although this is inside a cloud, the so-called cloud is a bit physical. You need quite a few servers. You need to dig quite a bit of material to design those servers and a lot of electricity to run them. So all of that is not thin air. All of that is material, and it's a lot of energy. It's a very energy intensive. The rate of increase is 24% per year of the quantity of data. So in equivalent in terms of energy, this is something that is increasing maybe by at least 10% per year. Even worse, if you look at the number of appliances, so the computers, smartphones, in IoT, you have a multiplicity of stupid material that are connected. Even your fridge now is connected. All of that increases the number of appliances that have been sold recently, because there's a big business behind it. And from 2014 to 2018, the increase of the number of appliances sold every year is 67%. So it's gigantic. It is usually people say that when it's a two-figure number, it's great for the business. Well, here it's not a two-figure number, it's 67%. This is amazing. And if you look precisely what it means, because it looks weird that we can sell so many things. Well, in 2012, in an American household, no, it's not American, it's OECD country, so whatever, a Western country, in a household of 4 people, people in 2012, they had on average 10 connected devices. 10 years later, in 2022, they have 50 connected devices. And it keeps going like this. It looks unstoppable. The problem is that, again, I said it's very energy intensive, and it's also material extensive. So here I like this figure because this is a representation. So it's an artistic modification of an actual picture. So this is one of those big mines. I think it's in Australia. Well, I'm not sure. I can't say. To be clear, all those paths, these are places where the trucks pass. So you have the gigantic trucks that go over those roads. So the depth of this thing is a few hundred meters. And what you see here is it's an artistic representation of actually the actual quantity of copper that has been removed from this gigantic mine. So we have this illusion that when you retrieve metal from the ground, it comes like this, like a nice ball of metal in a unique big stock. This is not the case. The reality is that in order to extract 1 gram of copper today, you have to extract 1 gram of, that's it. 1 gram of copper, you have to extract 100 kilograms of earth that you have to pile, to crush, and then to extract by a chemical action that is extremely polluting. It requires a lot of water, by the way. You extract almost no copper out of it. So from 100 kilograms, you extract 1 gram. And for even rarer metals like gold and others, it's even worse than that. To get 1 gram, you need 1 ton of material. So this is just impossible. It devastates the landscape. All of the debris are sent over because there's no regulation in the world. You have to know that there's no regulation. So the debris are sent over in the nature around. It goes into the water. It pollutes all of the water, and with all of the consequences we know now. So this is extremely intensive. And in addition, many of those mines are now out. They are over. We are in a situation. Sorry for this. We are in a situation today where the quantity of metals available is dropping very fast, and even if there is metal available, it gets more and more energy intensive to retrieve them. Okay, it's like for oil, you don't just now dig up a hole in the ground and get your hole for free. Now you have to dig deeper and deeper, and this is what the Americans are doing with their I don't know how you say in English, the hole that are retrieving now from mother rocks. I don't remember the name, but anyways, this is getting more and more energy intensive to get a bit of material. So we are in this situation today where all of those technologies to which we are extremely dependent, we are linked, and we cannot survive without, they will die soon. They are what some call zombie technologies, in the sense that they are alive, but they are almost dead because you cannot change them. So you may know about this already. We have a strong shortage in metal. So even today, to get a computer in France, so I don't know for you guys, but at least in France, to get a computer, it takes months because there is a sheer lack of material. And oil is, well, you guys are aware of that because of the geopolitical difficulties and the fact that things are getting rarer and rarer. In France, or in Europe, the price of energy is escalating. So we are in this situation where, well, things will stop inevitably, wish it or not. This will stop, and maybe it's for the good, because that means it will not be so harmful to the planet. So this is for the digital domain. Here I'm just giving a short focus on AI because well, the point was to talk about AI. I think AI is the worst on top of all of the digital domain for many reasons. One of them is that it's extremely energy intensive. So the deep neural networks today, so here I'm showing you a figure of the cost of training a single deep neural network for natural language processing. So I don't know for which task, so maybe to translate from one language to another. So you can look at those figures. They are from 2020, and it's even worse today. So those bars are giving you the, so let's look at the, well, at the yellow one. So the yellow one tells you that in order to train a machine, this is the equivalent to 500 tons, well, for this one at least, 500 tons of equivalent CO2. So 1 ton is what energy you would spend to take a plane from Paris to New York. So 500 is, well, 500 traveled from Paris to New York. And that's for just training a neural network. Okay, so a few years ago, even less than 10 years ago, we were designing softwares that you could program and compile on your computer, or maybe if it's not on your computer, it's on a small server, it will take a few days. Now, in order to train those things, you have to use 10,000 GPU cores in parallel and train them for a month. So people may tell me, okay, but it doesn't matter because once you've trained it, it's good, it's gone. You can use it as many times as you want. But the problem is that it doesn't work like this. In the industry, people are connected on Edge 24 on big servers to train their networks until you ultimately define, because all of that is a black box. So you find by chance a working design that you will run, and that will take you 500 tons CO2. So if you accumulate everything, this is just gigantic. In terms of energy consumption, this is, well, the best way to represent it is the cost, the economical cost is something like $1 million to train the machine in electricity, just in electricity. And I like also the blue figure that tells you if you were able to run it on your laptop, how long would it take? And in that case, it would take 400 years. So, so you can see how intensive it is. Even on a modern laptop that is supposedly good and performing with high performance. So this is going out of the sky. That doesn't make any sense comparatively to what we were doing before. And in addition, all of that is to design a machine for which we have absolutely no clue whatsoever what it's doing. It's a black box. It gives you a solution. Next time you train it, you're going to get another solution. You have no clue whatsoever. And you design machines that take the role of your own thinking, of your own decisions. So the more we go into AI, the more we create a world of machines that decide for us, that do the tasks that we used to be doing before, because apparently that's what we call liberty or freedom. Human freedom is to be released from all the tasks we have to do on a daily basis. The problem is that this also means that we lose our know-how, we lose our expertise. And today, even in agriculture, where AI is going to be more and more present, a peasant cannot any longer draw milk from his own cows because he doesn't know how to do it any longer. And he cannot even, well, do anything in the fields because everything is done by a tractor that is driven automatically using a GPS. He uses intrants that come from the industry sector. So he doesn't even know what is growing. So all of that is out of the agricultural hands. So we lose all of our know-how and all of that is displaced to the machines. And those machines, the problem is that they need a lot of energy. And this energy, well, you guys are aware of that. This energy is decreasing by the day. And very soon we're going to have a problem of shortage. So how do we do? How do we do the day when there is a major oil crisis and we cannot feed this system while we are all dependent on the system? We have lost our capability to do anything without the machines. So keeping on AI, just to show you that things are going worse and worse by the day, while we are supposedly, we have a necessity to do less, and the more we go, the faster and the faster it goes crazy. So before the age of deep neural networks, so this is 2012 here, what they call, I don't know, the first era and the modern era of artificial intelligence, there was something that was called the Moore's law that was saying that the capability of computers was doubling every 2 years. So every 2 years, the neural networks were twice as better than before. With deep neural networks, when we discovered that those things can do crazy stuff, now we intensively developed big servers with multiple cores, CPU cores in parallel, etc. And so the quantity of operations we can run on those computers is multiplied by 2 every 3 months. So it's 3.4 here. So every 3 months is doubling. So the slope is accelerating. So again, we need to go down by 7% per year. We're going up faster and faster. And so this is completely inconsistent. All of this big picture, well, is well represented by Sid here. I don't know if you guys know the movie. We are in trouble. And so hence the question, what should we do? So before I go into this, let me give a quick look at, so let me say it like this. When I somehow took consciousness of all of that, I realized that, okay, we are in deep trouble. We are in deep trouble, and it looks like there is no way out of it. So if there is no way out of it, the first reflex you have, if you don't want to get crazy, is just to forget about it and keep your daily life. The good thing is we have solutions. We know what we should do. And the first the first book I came across that gave me a kind of a way to figure out what's going wrong and what we should do is Ivan Illich from 73. So it's not recent, but those guys back in the 70s. So I told you that the mathematical model was also back from the 70s. Back in the 70s, people were very, very aware of what was going on. And it's interesting because those guys, they saw it coming, while today we are deep down into it and we don't even understand what's going on. Back in the 70s, people had realized. And so Illich, in a book that's called Tools for Conviviality, explained that the problem that we have, that we're facing, is that we are developing tools. We have been developing tools for 10,000 years. But those tools, they can exceed a limit where they become what he calls non-convivial. So what is a convivial tool? A convivial tool is like a hammer. It's a tool that extends your capability. If you want to nail a nail with your hand, it's harmful. If you do it with a hammer, it's more powerful. So it extends your capability. It extends your capability of action on your environment. But it has to be convivial. It has to remain a means, not a need. So once the tool has been so developed that you need it to survive, you now become dependent on your tool. And this is where it becomes non-convivial, because if this tool requires external energy or some rare metal, so external material to design it, then you're stuck with it. And this is what's happening with the digital domain. And also, this tool should not, in an environment where you have other tools, it should not be detrimental to the rest of the milieu where you live, okay, in the rest of the environment. And then a nice example is the comparison between a bike and a car. So a bike is very convivial because it increases your way of action. You can go further and faster using a bike than walking by foot. But even if you don't have a bike, and also the bike is not very expensive, so everyone can have a bike. It's very easy to repair, so you have a full control on your tool. And even if you don't own a bike, well, you can borrow one. And even if you cannot borrow one, well, you can still walk. It doesn't really matter, because at the end it will just take more time, but it works. And it's accessible to everyone. So a bike is very convivial. It increases your capacity of action. A car is not convivial. Obviously, when you have a car, you can increase your accessible space. So it's like a bike, much further than that, actually. But the problem is that your car, today at least, is not repairable any longer. I don't know of anyone, maybe probably in this room that can repair his own car when it's stuck. And with technologies going on, when you buy a Tesla today, if you have not updated the software of the Tesla, it doesn't even start. So it gets that crazy. You cannot even use it if you're stuck to it. Also, well, it's expensive. Not everyone can own a car. It's very deleterious to the planet because it needs raw material that are getting more and more rare and harmful in constructing it. Obviously, when you use it, you burn quite a bit of CO2, and we cannot afford that any longer. So even if it's an electrical car, electrical cars are actually even worse than thermal car. We can come back to it. But what is very important to understand is what Illich calls a radical monopoly. When you have a tool that creates a dependence to such an extreme point that it redesigns the population, it redesigns the way you configure the way you live. And this is what cars have allowed. We have now dense cities because of cars, because of trucks, because of the fact that we can squeeze in a lot of population, heavy population, because we can bring food from outside. It turns out that if you cut that down, if you don't have any trucks, any car any longer, every city, at least in France, I have the reference in France, every city in France can feed the equivalent of 2% of its population. The maximum being 8%. So that means that 90-something% of the population, if trucks are down, if there's an oil crisis, cannot survive just because we cannot bring the food inside. So this is the idea. Those tools, so cars, have changed the configuration of the way we live with our environment in such a way. So this is why it's called a radical monopoly. It has posed a monopoly on our geopolitical configuration, and in such a way that now we are completely dependent. We are stuck with it. And this is extremely dangerous. So, well, I'm going to skip over this, but Illich has if you read Tools for Conviviality, it's very interesting because it goes very far into the tools we use, and even, so cars are not convivial, even modern science is not convivial. I will skip over this. But you can even see that the health system is not, and the school system is not convivial. It's very interesting, this analysis. I don't have time for this. I'm just going to say that AI here at the bottom has problems of conviviality also. So, well, the good thing, indeed, AI increases our power of action because it allows machines to take decisions for us, so we can leave the machine do stuff that we maybe don't want to do. The problem is that we lose our know-how, our expertise, and this is the case more and more. You have to realize today that people can live, and people do live, in their couch. You can just sit in your couch all day long. The country will give you the money necessary for survival. You can call in delivery for food. You can watch TV to get informed, and that's it. You can live like this. And obviously that doesn't work if you don't have energy in the system. And so we are stuck with the fact that we have lost completely our capability to handle the environment. We cannot I guess most of us in the room cannot grow their own food. They cannot design their own house. They cannot protect themselves. If you are thrown into the forest or into the mountain, well, you cannot expect to survive very long. Well, we have killed all of the animals, so probably you're not going to be preyed by predators, but still, you don't survive very long because you need to feed yourself. So we have this dependence to the machine, to oil. I also always say oil because oil is crucial. If you don't have oil, you cannot just replace it by coal or whatever. We will have an oil cap in a few years. Maybe it's 2030. That's what is anticipated. Maybe it's a bit later. But all of the other energies are related to oil. And even if you go solar or or with wind turbines, you have a dependence. You still have a dependence on oil, one way or another. So we're stuck with that, and so we're stuck with this problem of resilience, in particular with digital technologies and AI. So what should we do out of it? So I'll try to go quickly over this. What should we, well, given what we know, given what the over specialization we have in our domains, what should we do from now on? So as I said at the beginning, I decided to quit altogether. Working on mathematics, AI, all of that is pointless to me. Well, the best, well, let's say, the positive viewpoint is to say that it's pointless. The negative viewpoint is to say that it's harmful. So I decided that it's harmful and I need to change and to do positive things. So what could you do? Well, the first thing is to realize again that high-techs, high-end technologies are maintaining a position where we are extremely dependent. We are what they call heteronomy. So we have a very high level of heteronomy. We are not autonomous. We have this high level of dependence on stuff that we don't control. So and as I said at some point, that's what people call zombie technologies. High-techs are zombie technologies because they are alive now, but they will die. And then even those that we imagine. So I don't know why people fantasize on 6G or quantum computing or all that bullshit. All of that will never emerge. Or if it does emerge, it will die very quickly afterwards. We should not go for it. We should not waste our energy and time for it. But that's my opinion. But we should think about two things together. We should think of irritating this high-tech world. How do we deconstruct? So what people call distorate. So instead of instaurate, you want to distorate, you want to decay the impact of high-techs on our modern world. So how do we live? Do we get trained to live with less and less high technologies so that we increase our level of autonomy? And at the same time, if those high-techs diminish in their impact, especially those high-techs that are fundamental for our survival. So high-techs that are fundamental for our survival are very dangerous. These are those that need to be destored as fast as possible, because when energy is cut, that means we cannot survive. So all those high-techs, those in agriculture in particular, they have to go down to disappear as fast as possible. And at the same time, to be replaced by low-end technologies, that is technologies that don't rely on resources that are not available, that will disappear in the future, and in particular on digital technologies. And so what is a low-tech? A low-tech is a technology that is compatible with this so-called conviviality. So that is, again, that increases your power of action, from which you are not dependent, that you can repair, that does not harm the environment around you, that is somehow regenerating. So what they call a life technology. So technology that can survive and replicate and live for long. Well, I'm not going to go too far into the detail. Just examples, by the way, of low techs that are used in to replace the digital things that are high tech today. You can create websites, so you can check out. It's very nice. This Solar Low Tech Magazine website that has been designed in such a way that it doesn't cost much. The website itself is very low energy. It doesn't contain a lot of kilobytes to be transferred, and it's powered by a solar panel. So doesn't mean that this is the way to go, but at least it's a way to decay the intensity of high-tech websites today, and maybe to imagine what would be a way to share information that we call internet today, and that is not sustainable. So how do we redesign the internet tomorrow? Well, there are experiments that have been done in order to create low-tech websites, low-tech servers that are based on on old mobile phones that are stuck in your drawers, for instance, in order not to reuse new material. There are other things that I'm going to maybe cover if I have a bit of time. But what is interesting is to figure out, okay, right, so I am an engineer. Tomorrow I want to work on low techs. What does that mean? Well, I think one nice representation of it is this kind of a picture. So this is something I designed, but obviously it's not, you don't take it for granted. It's something that can evolve. The way we do things today. So if you guys work on deep learning, on AI or whatever, you want to publish your article. Well, what you will do, you know that's what you have to do. You have to increase the performance of your algorithm. So you have an algorithm, you confront it to the state of the art, and if the performance is better, you will publish, you will get accepted. That's what we all do. The problem is that by having a single look at performance doesn't say if your method is robust, repairable, if it increases the power of action of the user. So maybe this technology is just bullshit. It's useless. You never asked. When we work on something, we are the ones that will design those systems, and we think it's useful. We never ask anyone if it's a need, if it's something that is really relevant for their survival or relevant for their well-being. So it doesn't mean that it increases their power of action. And also, we never question the fact that our technology, because it's very energy intensive, because it relies on metals, on rare metals, maybe is a problem when you don't have availability of resources. And also, if it's a black box based on AI, we never ask whether we understand, the user understand what is going on. And maybe that's dangerous, because the day when we don't have the energy available, the user will not be able to do anything else because he doesn't even understand what the machine is doing. So this is how I compare, and I'll show you an example right after for you to get a clear picture. This is where I compare an high-tech that has a better performance than the low-tech alternative. But the problem with the high-tech case is that possibly, it is in a danger of non-resilience, because it has many features that usually we don't take into account that make it a zombie technology. That is, that someday, how overnight, it can just disappear. It can just drop dead, and we may be stuck with it. We may be stuck because we need it. We need it, but it doesn't work. So when you design a low tech, you need to have what we call a systemic viewpoint on all of those things. Is it useful? Do people need it? If it breaks, can we repair it? Do we have the resources for it? Does it make sense locally and in a given time frame to transition into less and less technologies or less and less energy intensive technologies? All of that has to be taken into account. And so when you guys, that's what I advise now. When I am being asked, okay, what should I do? When you guys publish an article, submit an article, I consider that we should not just say, I compared versus state of the art and my algorithm is better. We should say, I don't care about performance. Maybe my algorithm is not so much better. Maybe it's worse, actually, in performance with respect to other techniques, but it's resilient. But this technology will stay and for hedges, and as long as I have electricity, I can it can be useful, whatever. And even if it drops dead at some point, the users get some information out of it. They can retrieve some know-how and expertise, and it's not a black box. Those kind of things. I think this is something that we should say now in our papers. In the abstract, or in the introduction, when we summarize all of the outcomes of our work, all our contributions, we must say that with respect to the coming crisis, or not the crisis, the fact that the Earth is evolving in a way that is very harmful, we are consistent. It makes sense. And so that may mean that we need to abandon altogether what we're doing. So random matrix theory for me is completely pointless. It has absolutely no point whatsoever in the evolution of the system. So I just quit and I do something else. And what is interesting here is that you cover such a wide spectrum that, as I will show you, I don't have much time, but as I will show you, it brings you very far, much further than your very short and narrow engineer expertise. You need to go much further than that in social sciences in particular. And I will cover that quickly afterwards. I'll just give you an example that you can find. Well, yes, it's in French, but okay. I'll just show you how it works. So it's a lady, Dr. Dacremont. She's works in the medical domain, and she attended sick children in Africa. So it's in Tanzania precisely. So to tell you about the situation quickly, the idea is that they have these dispensaries in Tanzania that are very far off small villages. And every day, people come with their sick children in the dispensary. And if they made all the travel to the dispensary, it's because the children are very sick. So that's what happens. And the problem is that in the dispensaries, they don't have professional doctors. So they don't have qualified medical doctors. So that means that at the end, the children arrive, we don't know how to treat them, so they give them the default medicines and they die with a very high mortality rate. So what the Professor Dacremont did was to figure that, okay, maybe we should provide the people working in this dispensary with some technology, so an AI-based machine that will take in the data from the children and give you a diagnosis. So this is what she did. She created a machine based on neural network. So she needed to redefine that because the typical sickness that people have in Tanzania are very different from other parts in the world. So she could not take off the shelf an existing technology. It never worked. The technology will always say that the children have the flu, which is ridiculous because they don't have the flu in Tanzania. But anyways, so she designed that. She put the algorithm on a tablet. And so, well, that was nice because the people working in the dispensary could just put in the figures and get the diagnosis. And this is nice. You had a very low mortality rate, so it worked. The problem is that the tablets, they need to be recharged. And in those villages, they run out of electricity very often. Also, because of the high level of humidity in Tanzania, the tablets will die very quickly. And also, they cannot afford replacing the tablets very often. It's very expensive. And worse than that, the very fact that the tablet is not working some days makes it that the people working in the dispensaries, they see that children will die while they could have been saved if you had electricity. So psychologically speaking, this is quite a big blow. They were better off without the tablet in a way. So she figured that, okay, all of that makes no sense. And also, well, something that she realized is that in order to design a tablet, you need to extract rare metals. Those rare metals come from outside somewhere else in the world. They have been mined by other children that die in those mines. So you're saving children in replacement for other children that die in the mine. So she said, okay, this makes absolutely no sense. So she thought of something different. She thought of this way of destoring high tech, turning that into a low tech. How did she do this? She changed the neural network into a technology that is providing an output that tells exactly the user what the machine did. So it was just a decision tree. And out of the algorithm, you knew exactly what the machine is doing, how you should think of using your data. And once you know this, you don't even need the tablet any longer. You don't need the pad. You just need a paperboard. And so this is what she did at the end. She had a very big paperboard that is now printed taped on the wall in the dispensary, where you have the big tree of decision tree. And with that, the very nice conclusion is that the mortality rate is the same as with the tablet. But now the people working in the dispensary, they have a new expertise. They know, they understand exactly what's going on. And even if the paperboard will be removed at some point, I don't know for what reason, well, they have the expertise. They can share the expertise. So they have the know-how. So this is how you move from destructing low high-techs, but using still somehow the idea of AI, because we live with it. We have an heritage of this knowledge of AI, and turning that into a low-tech version that is much, much more resilient, much more convivial in the sense of village. So, well, this is an example. I'll just finish on this, because this is how my thoughts have, so I've explored quite far, as I said, in human sciences in particular. And this is bringing me today to something extremely interesting in terms of what we call anthropology. So that is the study of how human populations, human beings configure their world, they compose their worlds. We have this thinking today that the world we live in is inevitable. There is some sort of a determinism that says that, well, human beings, they are harmful for other human beings, and they need always more and more and more. We need a new car, we need prices, we need to be satisfied from one, we always need more. And so in order to get more, we dig from the planet, we dig more and more, we extract, and when we are not satisfied, well, we conquer Ukraine because we don't have enough in Russia. So this is how we think the world is intended to be. Oops, there's something a bit bizarre here, sorry about this. This is not true. This is not true. This is something that is being true in the Western civilization. What anthropology has realized in the past few decades is that this is not automatic at all. In our Western civilization, since at least a few hundred years, this is the case. Why? Because structurally, so let's put things like this. Structurally, we all have, as human beings, we all know we have physical abilities. Okay, this is my blue stuff here. We have physical abilities. We have hands, we have legs, we can do things, we have a brain, we can reflect, etc. And we have consciousness. We have a subjective interiority. Okay, we have both of that. Now, this is true for all humans in the world. Now, what is different, and this is what they call structural anthropology, what is different from different populations in the world, everywhere in time and in places, is that we do allocate differently those two particularities, these two attributes, to the rest of the world. And in particular to the rest of the live beings. In our Western world, since 200 years, we live in what we call a naturalism cosmology or ontology. This means that we consider that the rest of the world, something that we call nature. Okay, I don't like the word nature. I'll come back to this. This is the worst word we have invented. We consider that human beings are isolated from the rest of the world that we call nature, and this nature has different physical abilities. Okay, animals, trees, they all have different physical abilities, physical ways of relating to their environment, but they don't have consciousness. And once you think of this, you can have you will have naturally a violent and direct, so sorry about this thing, a direct and violent action on the rest of the world. And this is what we've been doing. Everything that is not us, that is not human beings, is prone to extractism. And so we extract, we take more and more, and we kill, you may not know it, but we kill between 300 and 400 billions animals in the world every year for our human consumption. This is the equivalent to 1 billion per day. 1 billion per day. This is the population of all of America from the north to the south. Okay, from Canada to Argentina, the human population is 1 billion. Every single day on Earth, we kill these many living beings for feeding ourselves. This is just craziness. But okay, whatever. This is not craziness in a way, because we live in this naturalism world where we think that those beings, they don't have consciousness, so it doesn't really matter. And so the problem with naturalism, again, is that we will need more and more. And so we create conflicts of resources, and we go into this business of decay, going in these exponential slopes, and one day it will collapse. This is what I said at the very beginning. And it looks inevitable. Okay, it's something that it's deterministic. Human beings are like that. We don't have a choice. Well, again, this is not true at all. Actually, even the world we live in is an exception. It's an exception of a few hundred years, or maybe thousands, but it doesn't really matter. Human beings have lived for 300,000 years. We've never seen this typical behavior that we have now. However, in many, many, many other places on Earth, still today, there are different ways for human beings to see the world, and the extreme opposite to the way we do see the world is what we call animism. So the animism cosmology assumes that all the rest of the living beings, they all have physical abilities that are different from ours, no problem with that, same as for us. But, I mean, same as for our naturalistic viewpoint, but they have a subjective interiority. They have consciousness. And what is even more important in animism is that it's the same as ours. So animist people, they think that all other animals, they share the same capability as us to experience the rest of the world. And when you think about it, when you realize that you are yourself part of this world that share the same consciousness, and when you realize that our own atoms that compose our body is being replaced every 7 years. So that's something that has been proved. Every 7 years, all of the atoms in our body are being replaced by other atoms. Those other atoms, they come from the rest of the world, the rest of the living beings, the oxygen in the air that comes from the trees, the food you're fed with, all of that is just some sort of a continuum. So we are not just stuck in our body. We are a continuum with the rest of the world and the rest of the milieu we live in. And what is interesting is that for animist people, the other animals and even the trees experience the same thing as us. And in that case, you cannot you cannot be a predator on the rest of the environment. You cannot kill a pig the way you will do as in our Western civilization, because you're killing the equivalent to a human being, or someone very close to you at least. And so the way those people live, and it's still kind of the case today in some remote places. This is the case in Amazonia, in Antarctica, etc. In the North Pole, not in Antarctica. But anyways, in some places you have those small populations that have no intention whatsoever to grow in size. They have no intention whatsoever to to have an economical growth or whatever. For them, it doesn't even make any sense. They just live, they don't grow their population, they don't try to do better than their predecessor, because they are part of a world where no one is doing this. No other animal tries to do this. So why would you do the same? What would you do differently, since you are the same as the others? You experience the same world. And so I'm not going to push too far into this because I don't have time, but it's interesting to realize that we have different ways of seeing the world. And what is most important is that modern science manages to explain to us that it looks like animism is much more natural than naturalism. The first thing that we know is that kids, before they can speak, so kids, before they can be tainted by norms and by culture, they are animists. They think that the other animals and even the other objects, they have a consciousness. We can prove that. The experiments of social psychology prove that. The children, they do this by default. It's coded in our DNA. It's how coded in us that we think other animals, they have consciousness. And even better than that, we have followed animals and followed their what they call their geopolitical interaction, how they share their environment. And we realize today that the way they share the environment, the geopolitical behavior they have is much more elaborate than we thought before. Well, also, we know that some animals have consciousness, so this is clear now. There's no objection to this. But very importantly, animals, they behave together in a way that even human beings don't understand. Because today we live isolated from what we call nature, and so we don't even interact with the rest of the world. We don't interact with those animals and trees and stuff. Animals can do this. We cannot. We don't even understand. And even worse, even more, and I think I will conclude on this. Today, we know, and this is really amazing. Today, we know that trees, forests, are likely to also have a consciousness. What we know is that trees share information. This is very recent research. Trees share information in the air or below the earth through not mushrooms, but well, anyways, they share information from their roots and in the air. And those molecules that they share, some of them have the same function as neurotransmitters in our brain. So it looks like, functionally at least, a forest can be like a gigantic brain. So that brings questions with respect to, do they think? Do forests suffer? And we have examples of what they do. And in particular, one amazing thing that forests do is that when a whole tree dies and fall out, they keep feeding the tree. They take their own material, they take their own food, sugar, to push that in the old tree that have supposedly died, but they maintain them in life. And most likely, we don't know why, but most likely the reason is that the whole tree has experimented the environment for longer, and so can resend information backwards if it survives longer. So there is something amazing in that we think that the organization of a forest is made like a human brain, like a human society, actually, that you make survive the whole people that have the knowledge in order to be able to be more resilient. And this is the same for animals that can share an environment together in a better way than human beings are doing. So why do I say all of this? I say all of this because if we were animists and not, so we cannot turn overnight into animism, but if we were animists, we would not destroy the planet. We would not be in the current situation. And so when we ask today, what should we do? okay, we have gone too far. We know we have gone too far. We need to find some other direction. Most people will tell you, well, we need to do less. We need to make an effort. We need to have more and more constraint and to survive out of the constraints. This is terrible. If we say that our future is made of a lot of constraints, no one will buy that. And so we will just continue going on. And the rich people that can afford a little energy that will be less, they will keep pushing and destroying the rest of the planet until we cut the last tree. That has been seen in the past. If we think like this, we are dead. But it turns out that this way of thinking is not natural. Okay, when we are kids, we don't think of the world like that. And by the way, the way we think of the world today makes us sick, even psychologically speaking. People are sick. People don't sleep any longer at night. We are burning the planet. We don't even know what we're doing. We have no reason for living. All of that makes no sense. If we turn sequentially into thinking more and more as part of the system, part of the milieu we live in, and be incoherent, so be more related to the other beings, and make sure that we satisfy the needs for everyone. Okay, that's what they call adjusted consideration. So not thinking for yourself, or not thinking for your country, or thinking for whatever, not maximizing the benefit of some isolated group, but maximizing the benefit for all of the milieu, and being less individualistic. Well, it will naturally adjust, I think. So maybe it's a bit utopist, but at least science proves that this is more natural, and this makes us happier. At least it makes me happier, because this is what I experience now. And well, being more connected, banded to other people, other animals. So I go walk and run in the forest. I meet animals. I talk to them. I mean, talk to them, not verbally, but I exchange with them, and I see that we can connect. And it's very interesting to be in this situation, because it's a very different way of seeing the world. That a better way than being stuck in your four walls of concrete that make no sense, that are not your environment. And yeah, I'll skip over this. I will stop here so that we can take a few questions. And I thank you for listening. I don't know if we have questions in the chat. Yes.
Thank you, Romain, for your very frank and insightful presentation on this topic. It is a quite touchy topic and not always easy to deal with. So I'm asking to the audience if you have some questions. Yeah, well, I will start with a few questions. Maybe some will pop out later. Okay, me as a researcher, you know, okay, if we would like to act towards the good direction for low techness, my question is for you, how do you deal with the fundraising ecosystem that maybe is not always compatible with the green project, but green in the way that you defined it in the presentation? Yeah. How can we do that?
It will change. It will change. It's a necessity. It's already changing. I live in a lab where, so my lab, I should have said this, my team works on large national systems, and in particular on HPC, so high performance computation. All of them, almost all of the people in my team, they are in what we call cognitive dissonance. They know that what they are doing is harmful. They know it because the only place where they can sell their stuff is to Amazon or Total. Okay, this is where it's most efficient. Those people need that, and they are stuck because. And so some of my colleagues, what they do is divert their research into doing something extremely mathematical and abstract to be sure that their work will never be used. Can you realize this? We are as such a point of cognitive dissonance that people voluntarily destroy their relation to the world in a way by just doing mathematics for the sake of it. So at least they are safe, that it's not going to burn anything, it's not going to be harmful. So, okay, so my colleagues are in this position of mind, this set of mind today. They don't know how to change. So what I try to do is try to find new ways of thinking, of being more proactive. But most importantly, even my lab, so it's a lab of almost 400 people working in the lab. Even the heads of the lab, they realize that. So it's a lab of computer science. Even the heads of the lab, they realize that this cannot stay, we cannot live like this for ages. So they gave me money to hire, to recruit a postdoc, and some other parts I managed to have money for a PhD student. So it's coming. I don't know how they well, it's money that came from the industry somewhere, one way or another before, but it's been recycled, and now they are creating this how do you call that, a springboard to exploring further and further and starting a new activity. And it's going to be obvious that in the close future, companies will come and say, okay, we are in trouble. We don't have the metals anymore. We cannot sell our stuff. What should we do? And they will come and give you money to work on that. There's been a recent paper that says that the analysts think that 85% of the jobs in 2030 are not even decided. We don't know in 8 years from now what will be the repartition of 85% of the jobs, because they know that it's going to evolve extremely fast. So all of that is going to change. So it's not I don't think it's an argument to say, where does the money come from? Well, first of all, you need to redefine the way you work, what will be your contribution, and then money will come. That's what I think. Okay. Maybe faster, in some places than others, but at least for us in France, in Grenoble. So we live in Grenoble, so that's inside the French Alps. So in the mountains, the overheating of our place is not +2 degrees, it's +4 degrees. So we feel it. We don't have snow anymore in the snow stations as we had a few years ago. So we see it evolve extremely quickly. So we are scared. And people here are very, very scared. So it's changing very fast.
Okay, thank you. I have another question. I liked your idea of comparing pure performance AI versus some hexagonal performance, where you can assess energy consumption or something like that. Yes, yes. Yeah. So, but like me, as a applied researcher, I like some index, because it makes things easy to work on.
Yes.
Because sometimes you can feel that it's a bit blurred. So we need index to know, okay, this is better. So my question is, do you think that you can convert this sort of hexagonal table into something that is quite accurate as a performance index for like classification, for example, in AI?
So the answer is no, and it's better like this. The reason why we have never you don't come across with those spider charts like this hexagonal thing, as you say, is exactly because of what you say. It's interesting that you raise it out, because this is exactly the problem. People in science have been trained to think in numbers, and they have been trained to shut up and to have no political or subjective decision. Okay, if you're a good scientist, you give your figures and it's replicable, and there's no political judgment, militarism, or do you say this in English? Well, anyways, and the problem is that the world is not like this. The world is not all calculus. And there's been the problem in saying that everything must be measured creates also the same sort of radical monopoly that makes it that the only technologies we develop are those that we can measure. And so there's a whole other part of the world that is less touchable, less tractable, that we just forget because you cannot put it in numbers. So to your answer, yes, no, we do. Sorry, no, you don't have figures, strict figures for the power of action of the user. However, you can compare, you can discuss. And when you read Illich, I think this is my reference. When you read the work of Ivan Illich, you realize that you can prove things extremely accurately without a mathematical symbol, and that you don't need quantification of everything. And as for precisely the context of low techs and or technologies, you can compare. You know how to compare things one to another. So maybe you cannot say exactly it's going to be 80 out of 100 or whatever, but you can compare one to the other, and you know which one you should keep, especially if one is more consistent on the full diagram than another. This is the idea. And I think, again, you're touching exactly a key point that makes it that we refuse today as positive scientists to deal with anything else than our very narrow domain. And we don't want to touch the human sciences because it's too vague, because it's debatable, etc. If we refuse this, we refuse the systemic part of the world. Let me just give you an example quickly. A colleague of mine told me that he went to a conference where the first panelist was talking about the new, so it was in Airbus, I guess a guy from Airbus who had designed a new plane that is zero carbon emission, zero carbon emission plane. Wow, amazing. But obviously, it was running on electricity batteries or I don't know, I don't remember exactly, but he was asked, but okay, zero carbon, but where does the electricity come from? Where does the battery come from? And the guy answered, well, it's not of my business. It's zero carbon once the plane has been designed. And since the electricity was coming from nuclear power plant or whatever, renewables, he said it's zero carbon emission. But this is completely ridiculous. This is a very narrow-sighted viewpoint. And if you just get stuck in your local domain, you can say a lot of bullshit like this. And you could say, and this is exactly what we are saying today, you could say that it's good to electrify the automobile business, the automobile sector, and have all electrical cars in place of thermal cars, while if you do a full analysis of the spider chart, you would realize that electrical cars are much, much more harmful than thermal cars, and we don't want them. It would be super dangerous to do this. But of course, when you are restricted to do your local domain, an electrical car doesn't produce one bit of CO2, so it looks like it's perfect. So this is really important, to be capable of going transdisciplinary, to cover everything. And so to the question, what am I doing now? I just read about everything. You need to read about everything and get interested to everything as when you were children. When we were children, I guess most of us were interested into everything. We were asking what to all of these things in the world. And then the society trained you into being an expert of nothing, an expert of a very narrow, a narrow field that maybe 10 people in the world can understand. And you're proud of it, but actually you don't know anything about the rest of the world. And when you were kids, you like to know about everything. And so, and we are scientists, so it's very a waste of our resources, our capabilities, to just work on something extremely narrow that is completely stupid and useless. So this is what my state of mind today. I explore the rest of the information about the systemic behavior of the world, system dynamics, all the way up to anthropology, as I explained. And all of that creates a mental picture that is much more interesting than the mental picture I had when I was an expert of random matrix theory. So,
Thank you. I see that we are a bit we are beyond the schedule, not a bit, like almost half an hour. I would like to take a question from Laurent Clavier, asking a question. The change is radical, but don't you think that there is a trade-off to be found where some so-called dangerous technologies can also help to go on the right path?
This is, yeah. So this is all this business that I call destoring low high techs. Yes, you cannot change overnight into going low tech. And also that takes technologies, but that also takes psychology. You need, and time and place. You need to manage to convince people to move into something more rightful. But people have been changed in their way of seeing the world into thinking that the less you do, the better it is, which at the conclusion, by the way, makes them sick because they eat stupid things, they drink polluted water, and they are psychologically distressed. But still, they have been convinced that the more you hone and the less you do, the better. So we need also, this is psychological change of mind. So this is why I talked about this anthropologist thing at the end. You need to convince people that it's beneficial for them to be more connected to their world, to understand their world differently, to see it differently, to compose it differently, because this is the way to transform what's currently is seen as an effort to do and that no one wants to do into something more profitable. So there is this psychological part that needs to be changed, and this is from a political level. This is from a collective level. We need to have more self-helping, to be closer to the others. All of that needs to change in the society before we adhere to the fact that we will do less. We will use less high-tech. It's difficult to ask someone today to cut off their Facebook account or all of that. So this is a change of mind. This is the most difficult part. But we are in capability as scientists to explain all of that, because science is behind us, helping us to understand that this is the right way to go. And once we have that settled in the mind of people, or at least people evolve in this direction and they understand this is the right way to go, there is this transition from moving out of high-techs into low-techs, or whatever you call it, out of zombie technologies into regenerative technologies that can survive for long, that will come more naturally. And so this is, by the way, answering another question, which is, what are the needs? What are the needs? We don't want to be like we do now. We don't want to be expert deciding of what we should do, what people should do, what we should build for them. We need to hear what people need exactly, what are their true needs in order to answer those needs. So we should do our research outside the university. Get out of your room, get out of your office, and ask people, meet the civilian associations and all the people contributing in the society to understand what people actually need and what the society needs, not what we decide they need, which is the big problem in the digital business. We have created the needs. No one had a smartphone before, they lived happily, and now we have a smartphone, we cannot live without it. So yeah, this is a whole intricate thing. I don't have a solution, but this is my idea.
Like, it's not a problem toward a solution, it's a predicament with like many problems with many little solutions. So we have to redefine the way to
yes.
We have to redefine what is the solution in this context. Okay. Thank you so much again for coming. I see we are beyond the schedule, so I propose to stop now. And the YouTube, this conference will be released on the YouTube channel. So
Okay.
please don't hesitate to share and spread the word to share this presentation. That was very insightful. So thank you also for the audience for coming and attending, and thank you again, Romain. It was an honor to have you here.
Yes, thanks for the invitation.